Earlier this week, we saw isosceles triangles, so we're going to be talking about equilateral triangles. So from isosceles triangle, we were able to get two of the theorems, which was the base angle theorem and also its converse. So from there, we're able to get two more theorems for equilateral triangles. So if you have a triangle that's equilateral, then it's going to be equal angular, which means when you have an equilateral triangle, all three sides are going to be congruent and also all three angles are going to be congruent. And from here, we also know that the converse is true. So we're going to be using the property for equilateral triangles and for isosceles triangles to work out some problems here. Let's go ahead and notice how the diagram is labeled here. So all the angles have one arc, which means they're all equal. And because the sum of all three angles in a triangle are congruent, then each of those angles need to be 60 degrees. The sides, they vary. But in an equilateral triangle, all the angles are 60 degrees. Let's review what we know about isosceles triangle. So in an isosceles triangle, we know that two sides are congruent, which are called the legs. The third side is called the base, and we know that the base angles are congruent. So we're going to use properties for equilateral and for isosceles triangles in the following problems. Notice how the base angles are attached to the third side of the isosceles triangle. Okay, so we have two triangles here. I like to label them triangle 1 and 2, and I always start with the one that gives me more information. So in this case, triangle 1 gives me more information. I know that all three angles are congruent, which means it's an equilateral triangle. And if it's an equilateral triangle, then all the sides are also congruent. So since we know that one side is 4, that means that y would need to be 4 as well. And then from here, we're going to go ahead and move to our second triangle, which is where x is located. So x is located on one of the sides of the second triangle. Now to do that, we have to get some information from triangle 2. So we know that those two angles are congruent since they have two arcs. That means that we have an isosceles triangle. So that means that the opposite sides of the base angles are congruent. Now, what do we know about the left side of triangle 2? We know that it's 4, since we said that K and L was an equilateral triangle. So since we know that the legs are congruent, then we just set them equal to each other and we solve for x. So in this case, x equals 3. For the second one, I'm going to have a similar approach. So I'm going to label one of the triangles 1, the second triangle 2. I always start with my equilateral triangles because those give me the most information. I know that all three sides are going to be the same, and I know that all three angles are going to be the same. So for triangle 1, we know it's equilateral since each of the sides have 2 marks. So that means that they're all the same. They all have the same measurement. They're all the sides are congruent. And I'm looking for angle. X is an angle. That means that x equals 60. Since in an equilateral triangle, all the angles are 60 degrees, since they need to add up to 180. Now, to move to the second triangle, we're going to notice that part of one of the angles in triangle 1 and part of an angle in triangle 2 form a right angle. We know that The part that's in angle 1 is 60, so the part that's in angle 2 needs to be 30 degrees. Now we're going to move on to triangle 2 since we have information about it now. And this one's an isosceles triangle since two of the sides are congruent. So the base angles are going to be congruent. So those two angles will be 30 degrees. And to find out the second triangle, we're going to use the fact that the sum in any triangle the sum of all the angles in any triangle equal to 180. And what we're going to do is we're going to subtract the angles that we already have, which is 30 and 30, from the 180, and the remaining part will be that angle that we're looking for, which happens to be y. So y would be 120 degrees. So moral of the story is start with the triangle that has the most information. If you have an equilateral triangle, then you're best off starting with that one. Same approach, triangle 1, triangle 2. Just like I mentioned, I'm going to start with my equilateral triangle. I have an equal angular triangle here, so that means I have an equilateral triangle as well. All the sides are going to be the same. Let's go ahead and mark them. Since one of the sides is 40, that means that 8y needs to equal 40. Do some algebra here. That means that y is 5. Let's go ahead and move on to triangle 2. We just found that one of the sides from triangle 2 is 40. And we were given that another side was 40. That means we have an isosceles triangle, since those two sides are congruent. Which means that the base angles, the ones that I'm marking right now, will also be congruent. Now, I can't fully find x yet until I know at least one of the angles inside triangle 2. To do that, I'm going to use one of the angles inside triangle 1. Okay, we're going to call that angle A, the one that I just labeled. If I look at the angle right next to A, which we're going to call it B, I notice that those two angles form a straight line. And if it forms a straight line, then it's going to measure 180 degrees. So angle 1 plus angle A would be 180. We know that angle A is 60, so angle B will need to be 120 degrees. So that together, they add up to 180. Let's go ahead and label that in the diagram. Now we're going to use that now to help us find the measurements of the base angles. So if you know that all three angles in a triangle need to add up to 180, and you know one of them already, let's go ahead and find out what the remaining parts will be, which is 60. But from that 60, I have two angles, so I'm going to split it into two parts, or into two angles here. And we're going to notice that each of them need to measure 30 degrees. So x equals 30. So you found what you needed, x and y.